You've been hearing this for like 10 years, right? A function takes an input and maps it to an output. That's what we've been talking about the whole time, right? We're taking an input, the result of rolling a die, and mapping it to an output, a number on the real number line. That's it. That's like the accumulation of all of this. The probability that a random variable takes on a realization is captured in this function. And this function is what we're used to seeing. It could be the function of the normal distribution or the exponential or the negative binomial. That is what this function is. It assigns a probability to a realization, assigns a probability to this event occurring. And this is our typical notation. The function that the random variable capital X equals the realization lowercase x. It's super confusing because a lot of people write x is the same for capital and lowercase. But our capital represents the random variable and our lowercase represents a realization. Now, like we just said, this realization is going to be a number, but the underlying event that it occurs could be anything. It could be the event in which it rains tomorrow, or the event in which you flip a heads. It's only after we translate it to a number that we can then put it into the function. So it's only after we translate the event into a number that we can put it into the function and determine the probability. That's why we need the assignment in the first place. So for example, we could find the probability that my test score was less than 80, which is 0, it doesn't happen. But we can't directly find the probability that the weather tomorrow will equal rain if we don't assign rain a real number. The probability that the weather tomorrow will equal rain, this is almost all the way to complete notation, but we need to assign this yet into a real number so we can operate on it rather than just using words. Or we could find the probability that the result of a die roll is an element of 2, 4, or 6. In other words, it's an even value. Now here's the best part. If we take the probabilities of each event occurring, so the probability of giving it 79 and 78 and 76, etc., all those realizations, if we plot those, that's the probability density function. That's a PDF. If we plot our realizations on this axis, and the probability of each realization occurring on this axis, maybe I'm most likely to get a 90, but if I have a bad day, I'll get a 70, and if I have a really good day, I'll get a 105, right? This is what the probability density function is. We're just plotting all the realizations with their corresponding probability. So in conclusion, y is a random variable, neither random nor variable. Because typically when we think of random, we think of, well, it could be anything. But in reality, there's a very specific chance of rolling a 1 or a very specific chance of it raining tomorrow. It's not just up to fate. It's not just like a completely random. It's determined by the PDF, right? It's determined by that shape. Now, the technical reason that we use the word random is because the outcome of the event is unknown until the experiment actually happens. Because we do know that there's a probability that we'll roll a 1 out of 6, but we don't really know what the realization is until we actually roll it. So in that sense, it's random because it's uncertain. So it should be called an uncertain variable. And it's not really technically a variable because there's a specific domain of realizations that the random variable can take on. It can't just be anything, right? It can either be only a 1 or a 0 if it's heads or tails, or integers 1 through 6 if we're rolling a die. It can't just be anything. For example, we can only have the integers 0 or 1 if we're flipping a coin and we assign a heads to one of these and a tails to the other. So why do we use the word variable in the definition? Well, a variable can take on values that are different, right? And so we can take on either a 0 or the 1. There's variation, right? It's a variable in the sense of it could be a 0 or it could be a 1. So that's why we use the word variable in the definition of it. So in conclusion, what should you remember? Well, a random variable is really a function. What do functions do? They assign or they map or they translate. What does it translate? An event into a number. That's what a random variable is. Thanks for watching.